Hello, welcome to today's class. Today we'll be talking about chapter 4, and by the end of this class, we've already learned how to use StatCrunch to um, produce number summary. We've already talked about histogram in our previous chapters. Today we'll be focusing more on box plots, and then remember we've already spoken about how we measure center and spread. We will look into more details on that, and then we would also make time plot and then also archive. So the five number summary, remember these summaries are for quantitative data set. These are for quantitative data set. And so the five number summary is the mean Q1, which is the same as the 25th percentile, the median Q3, and the max. They should always be in this order, right? So minimum first, followed by Q1, the first quartile, the median, which is the same as the second quartile or the 50th percentile, and then the 75th percentile, which is the same as Q3, and then the max. Once we have this information, we can be able to summarize this information using a box plot. And so this is how a box plot looks like. So this box plot is vertical. It can also be horizontal. So if it's horizontal, it means that it is going to look something like this, right? So I just want you to know that it's the same information. So there's the vertical one, horizontal could also be this. It doesn't change anything. So once you have your box plot, it is very good to be able to know what information can you identify or can you see on this box plot. So the first thing we are going to look at is, so this thing here is Q1 or the first quartile. This line here is the median. This line here is Q3. So anytime you have a box plot, you should be able to identify these first three. And also know that the length of this box here, that is the interquartile range, the IQR. Remember, we said the IQR, it is Q3 minus Q1. So just know that the length of this box here, it is the IQR. These lines here are what we call whiskers. So these lines are the whiskers. And then usually when you have outliers present in the data, you'd see them. So for example, this data point here is an outlier. So it's a lower outlier. And sometimes you could also have a couple of them also up here. You see, so those are also outliers, but the upper outliers. We will talk more about the rule for labeling outliers in the next slide. But I wanted to draw your attention that when you have a box plot, outliers could be displayed this way. And then this line here, it is the lowest extreme value found within the lower fences. So this is the lower extreme value found within the lower fences. And also this is the upper extreme value found within the upper fences. So numbers beyond these fences are called outliers. And so we would look at how do we determine the fences. And so this is how we determine the fences. So numbers outside of this range are outliers. And then numbers outside of this range are extreme outliers. Also, if the median is not centered or if the median is not in the middle, so you can see this one like this, the median is almost centered. So then that is, if the median is not centered, it means that the distribution is skewed. It means that the distribution is skewed. Okay, now we want to go into StatCrunch, and then we are going to use this data set. So the question here is that we are going to be able to remember we use box plots to analyze data sets, especially when we have various groups, because the box plots easily provides information right away. Looking at them, you can be able to make meaning of the data using those various groups. And so we are going to look at that. And so to be able to do that, we are going to focus on this data set. And the question here is that, do men and women in the US marry at the same age? And so the data are the average ages for first-time marriages for US citizens from 1890 to 1998. So this is the data set we have. So we are going straight into StatCrunch, load the data, show the 5-number summary, and then think about, so now because we have various groups, what groups do we have here? We have men and women. And remember, ages is what quantitative. That is why we can be able to display the 5-number summary for this data set. And then we are going to also show the box plot for the ages for women and that of men. And then we'll see if we could be able to answer this question here. So now let's get straight into StatCrunch. There we go. So now we are in StatCrunch, and so we want to load the data set. So we go to data, and then we go to data load from shared data set. And then let's try to type in CH4. Let's see. We are going to use this data set. It should be CH4, e.g. marriage age. So we'll click on this one here. Good. Now we have the data set. So you can see this is year. This is the average age for first time marriage for US citizens for women, and then this is also for men. Now let's construct the 5-number summary. So to be able to do that, we go to stats, summary stats. Let's get to columns. And so our columns are men and women. Okay. The columns are men and then women. And then what do we want to show? We want to show the 5-number summary. The 5-number summary starts from the minimum, quarter one, median, quarter three, and then max. And then we hit compute. So now we can see this is the 5-number summary. When you look at the 5-number summary here, you can also try to make meaning of it. So you can see that the lowest age for women to marry, or the lowest age that women marry, is 20.1, which is a bit lower than that of men. So you see with this summary, you can be able to make meaning of that. You could also see that the maximum age for men is also higher than women. So, and then we can also see, so now we can see this thing here, and then we can also see both the Q1 and then for both of them, Q3 for both of them. So this is how to produce the summary statistics, the 5-number summary. So we've done with that. Now, the next thing we want to do is how do we answer the question, do men and women in the US marry at the same age? Well, this summary statistics is giving us some insight, right? Because we can see from the summary statistics that the minimum age, or you can see also the center, this is also the center. So you can see the average age for, or the median age for women to marry is, or the median age for women who marry in the US is lower than that of men, right? This is also giving us an insight. Can we also do this using graphical means? Yes. And the best tool to use is box plot. We could also use histograms for both of them, but box plots help us to be able to answer this question more appropriately. So let's try to do box plots. So to do box plot, we come to graph, we go to box plot, we click on that, and then the columns is men and then women, right? And then we could also use fences to identify outliers. We could also decide to do the box plots. It's the box plots horizontally if we want. And so then we have compute. So you see, now when we look at this box plot, the first thing we can see is that there are no outliers. Remember, if there are outliers, it's going to be above the fences. You'd see some circles or some dots above the fences, either on the upper fences or the lower fences. So you can see the first thing we can see is that there are no outliers. Good. Now you see, this is the box plot for women. This is the box plot for men. Now from here, we can also see that this data is slightly skewed for both men and women. How do we see that? Now let's look at this. Remember, this box here is the IQR. Now look at where the median is. The median is not in the center exactly, you see. Look at where the median is. Look at where the median is. So we can see that, the median is lower than the mean. So from here, we can see that our distribution is slightly skewed to the right, right? You can see that distribution is slightly skewed to the right. And we did that by looking at just the box plots. Now look at the median. If it's symmetric, it should be somewhere here. It should be like in the middle. right? So that is the first thing we can also see. And then now, when you hover your mouse around this, you can see that this is giving you the, you see, it's giving you the Q1, the median, the Q3, the upper limit, the lower limit, and all that. It also gives you, you see this thing here, it gives you the Q3. This gives you the Q1. You see, there's the upper limit. There's also the lower limit. Same thing. So when you hover your mouse, it gives you the various values as well. Now, what can we see from here? So now when we look at this, we are trying to answer, do men and women marry? Do men and women in the US marry at the same age? Now, the answer is that, now you can see the box plots. This one is a bit higher than this one. You can see here. Look at the median age for men. Look at the median age for women. So we can see from this box plots that women in the US seem to marry early in life than men. Or we can say that men in the US seem to marry later in life than women, right? So we've been able to answer this. They do not marry at the same age, but instead, men marry later in life in the US than women based on this data set. So you see the importance of using box plot when we have data set, when we have groups, right? And we use data set, we use box plots for quantitative variables. The other thing I want to show, a plot I want to show here is the I want to show this plot. It's called the time plot. So the time plot, usually when we have data set, I'll talk about it in the later slides, but I just want to show it now. When we have data set where we have usually, so the time plot shows the time versus the data. So you see in this data set here, we could also use the time plot because now we have time. So year, when we have month, you see, so we have the year and then the data set. So we could also draw time plots to be able to also have some insights about the data. So now let's try to also produce the time plot. So same thing, we go to graph, then we go to multi-plot, and then anytime we want to show the time plot, our x variable is always the time. So in this situation, our x variable is going to be the year. And then what is our y variable? So our y variable is going to be both men and women. So we start with women first. What do we want to plot? We want to plot both points and lines. And then we click on add. Now we change this to men and then we click on add. And then we just hit compute. You see, now we can see that almost at every year, the women marry early. Almost at every time, the women marry earlier than men. And then we can also see that now when we are getting to the 2000s, you can see that the average age for both men and women to marry in the US is rising. You can see from here. Why is it so? It could be because now people are getting more educated. People want to finish their PhDs before they get married. People want to be able to finish their certifications. People are in school. So there could be a whole lot of factors that could be contributing to this. But you see, the time plot is giving us insight. And we can also see from here that in the 1960s, the average age for women, that is when the average age for women was, so women were marrying earlier in those years, and you can see the men also dropped, but now the trend is changing a bit. So that is the essence of also having a time plot. So the time plot, anytime we have a data where we have time, so the time plot shows a data, it just shows a plot of what time versus the data. So that is what a time plot shows. Okay, so now that we've been able to answer this question, let's get back to our slides and then we can proceed from there. Okay, now we also want to do example two. Let's try to read the problem and then let's make meaning of the problem before we go and analyze it and start crunch. So the problem is saying that for her class project, a student compared the efficiency of various, so she's comparing the efficiency of various coffee cups. So she's comparing four different cups, testing them 8 different times. Each time, she heated the water to 180 degrees Fahrenheit, and then poured it into a cup and sealed it. Then, after 30 minutes, she measured the temperature again and recorded the difference in temperature. She's recording what? The difference in temperature. So what it means is that, so initially it's 180. So now if she measures the temperature now, and then let's say it's 175, so she's going to record 5. That is what it means. So because the temperature different, because these are temperature differences, so it means a smaller difference means that the liquid stayed hot, because now if it is 180 degrees and then now she measures and it's say 179, it means the difference is 1 degrees Fahrenheit. Then that means that there was lit, so it means that the liquid is hot in the cup. So the key thing here is to be able to understand what we are doing. So now that we've understood this, and then she's comparing four different cups. So we are going to look at the data set and start crunch, and then show the 5 number summary, construct the box plots, and then also what can we say about the effectiveness of these four cups. Right. Now let's move to start crunch again. So it's very important that we understand this data. So try to write the questions down and also the various elements or the various key things in the problem, so that when we get to the data, we could be able to analyze it more effectively. Let's get to start crunch. There we go. This time around, let's load a different data set. So let's go to load, and then let's go to share data set. And then let's type in cap txt. Let's do cap. Let's get to let's get to data load, share data set. Okay, there we go. So this is the data set we want. So cap txt, it's caps. Let me see. Yep, now it's here. So it should be caps. I'll fix that in the slides. So caps, there we go. So now we have this data set now. So let's try to produce the 5-number summary first. So to do that, we go to stats, summary stats, columns. And so we want to produce, which column do we want? So difference, and then we should group them by container, right? And then we want to show the 5-number summary. So minimum Q1, median Q3, max, and then we hit compute. So we see, even just looking at this here, just looking at this 5-number summary, we could be able to make meaning. So just looking at this, we can just see here that the Nissan cap is doing well, because you can see the difference in temperature here. The minimum is 0, right? Which means that there was little to zero drop in temperature. Remember, we are measuring the data here is a difference, right? And you can see even the maximum is 7. But look at the SIG cap. It's not doing well at all, right? And then the minimum is 9, a drop in 9 degrees Fahrenheit. So somebody who is a coffee drinker would be able to notice these huge differences. And somebody who always wants their liquid hot would not prefer the SIG cap. So just looking at this number summary, it's helping us make some insights, right? This number, StatCrunch produces them for you, but you have to be able to understand and also draw some inferences based on this summary statistics. That is what statistics is about. We are trying to make meaning out of the data. So we have this. Now, the next thing we want to do is to construct the box plot. So I close this, I go to graph, and then we get to box plot, and then this is difference. We should group them by container, and then you convert them horizontally if you want. That is up to you. And then we hit compute. So now the question, now that we've been able to construct a box plot, now the question is that what can we say about the effectiveness of these graphs or of these plots? So now look at this and think about it for a minute. Remember, the data is a difference, right? So first and foremost, we can see that the data, they are all both slightly skewed to the right. Now you can see, because look at where the median is. Look at Q1, median, and then Q3. You see where Q2 is, so it shows that even for SIG, it is skewed to the right. Same thing for the Starbucks cap. Same thing for the Nissan, but the Nissan is not as skewed as SIG. And then also same thing for caps as well. So that is the first thing we could also see. We could also notice that there are no outliers. Another point to also note. Remember, if there are outliers, there would be some points beyond these fences. Sometimes it could be lower, sometimes it could be on the upper side. Good. Now we can see that this box plot goes to confirm what we saw in the 5-number summary. We can see that the Nissan cap does the best job of keeping the liquid hot with a median loss of temperature of about 2 degrees Fahrenheit, right? Remember, the lower the difference, the better, or the more it means that the liquid in the cup is hot, right? So we can see that the Nissan cap is doing the best job, because that is the only cap with the lowest median difference. That is the first thing we could see. The other thing we could also see is that the silk cap is the worst, right? We could see that the silk cap, look at the median is about 14.25, right? So the median is typically losing about 14 degrees Fahrenheit, right? So it means that if you put a liquid or a hot liquid into this silk cup, it will get cold earlier than the others. So these are some of the things we could be able to, or these are some of the inferences we could be able to make on this box plot. Now, the other thing you could also see, now look at the boxes here. Now look at the boxes here. Can you see that the boxes for the Nissan is the shortest? Now look at this one here. So what does it mean? Remember, these boxes here are the IQR in the interquartile range, which we talked about at the beginning of this class. And then remember, in our previous chapters, we learned that we also use IQR to measure variations. And then remember the example we did about the playground and then the classroom. And so you can see here that the variation is very small. What it means is that the the Nissan Cup is a consistent performer. That because the variation is small, it means that it is consistent. So that this is some of the insights or inferences we could be able to draw from this box plots. Good. Now let's move to our slide. Oh, okay, so we've been able to do this. Now we want to talk about, we've already talked about the time plot when we drew the graph for the marriage. So that is what I wanted to draw your attention to. So we've already discussed the time plot. The other thing we want to talk about is the ogive. It is a graph that shows the percentile versus the values. So for example, we want to plot the ogive for the sec cap, right? So because it's a graph of percentile, we want to show, so we want to draw that. So you see, look at the mean, median, first quartile or Q1, median, upper quartile, and then the maximum, right? And so this is the summary statistics from the SIG example. I placed it in the table here. So how do we construct the ogive for this? Remember, the ogive is a graph of what percentile versus the value graph. Now, let's look at this one here. So you see, so this is the percentile. And then this is the what? The data values. Okay. And then you see, look at where the mean is like same as the 0th percentile. So you see, the maximum is the same as the 100th percentile. And then the Q1 is the same as the 25th percentile. So 25th percentile, you see, the 50th percentile is the same as the median. And then the 75th percentile is the same as the upper quartile. You see, and you trace it this. So this is how to construct the ogive. That is all for this chapter, and I'll see you in future chapters. Thank you for your time.